All right, folks, welcome back for day 2 of the AI assisted programming part of AI Summer. I'm Sharo Bell. I'm a senior data scientist here at the DSI. You already know us, but I'm joined by Jesse Spencer-Smith, the chief data scientist at the DSI, as well as Miranda Shirk, who is a senior data scientist, Umang Chaudhry, who is a data scientist at the DSI, and Abby Petulante, who is our postdoc at the DSI. Welcome back, folks. It's great to see you. All right, so I would like to start off by just answering any burning questions that you have about what we did in the last session. Any burning, blazing questions? No burning, blazing questions. Give me a second. I'll give us, people are still filtering in. So I'm just going to wait a second, see if there are any burning, blazing questions. All right, great. It looks like there are none. Well, fantastic. So as one of my favorite creators says on TikTok, no time for an introduction. Let's just jump right in. Love it. So today, what we're going to be talking about, as promised, is a little bit more about functions, packages, and APIs. And so this is going to be sort of an interesting class because it covers concepts that are usually covered in a second-year programming course, but it's really helpful to have this background if you are working with APIs and packages. If something goes wrong in them, or you have something to debug, or maybe you want to try to implement something yourself, this is really great knowledge to have. Otherwise, it's just really nice to know what you're looking at when you go and look at these different APIs that we'll be using. Next week, Miranda and Umang will be talking about LangChain, and so we'll have a little bit of an introduction there, just to relate it to packages and APIs. But I think it's going to be a really interesting class. And so there may be some little hurdles to overcome, but I mean, learning is full of hurdles, so we'll overcome them. One last thing before we get all the way in and get started, please feel free to either raise your hand by the reactions. If we ask questions, please feel free to just put your answers into the chat. There's no judgment here. We're all learning together. You saw me make a mistake when I was live coding on last week and someone helped correct me. I got some private messages, but I looked at them like, no, we'll just tell the public. It's gonna, it's gonna affect everyone. So that is a part of programming, getting errors and then debugging them. So please feel free to just respond freely. Don't worry about being wrong. Again, we're all here to learn. So let us then begin with the learning. So I am going to send the link to the repo. It should be looking super familiar. I'm going to put in the chat. Oh. All right, and today, as normal, we're going to be using breakout rooms. We're going to be in Google Colab. It's going to be a fun time. So let me go ahead and just share my screen. Everyone get started by going to the repository, and I will get there myself. There we go. All right, so here is our repo. As we said yesterday, just in case there are people here that weren't, not yesterday, on Monday, if there were people here that weren't here on Monday, what we're looking at here is a repository. These are a bunch of Python notebooks. And so we're just going to select one of them here that we're going to be talking about today. This notebook here, anything that has solutions at the end, it contains pretty much all the code that we're going to be running. If you happen to fall behind or you just want some more context, please feel free to look at those. Otherwise, we'll generally be working in these notebooks that look like this. And in fact, we're going to be looking at this exact notebook. So let's go ahead and click on that one. Thing about this is we're just sort of viewing the notebook. We can't interact with this at all. It doesn't have a kernel, as we talked about yesterday. It can't do any processing. So what we do is we open in Colab, we use this blue badge, we click on it, and then this opens us up to the capacity to actually do some programming on a real kernel. Yesterday, we said this Google Colab has a lot of nice functionality that we enjoy. And so today we'll be exploring, again, functions. So essentially in this class, the goal is to understand functions, but also understand some components of object-oriented programming. And so that will have to do with classes and a little bit about inheritance and polymorphism there. But it is really all in pursuit of understanding how we're interacting with packages. And when we go to these APIs and they have quick starts, when you look at them, you'll be able to say, oh my gosh, like I actually wrote the code that can do that as well. So just know that that's the goal. We're going to be kind of relating them together so they kind of glue in your mind. All right. One other thing is that everything you need isn't quite implemented in this code. So I have left something very important out at the top. You usually see this at the top of all like Colab notebooks. It is left out because that is something that we're going to, make sure that you're thinking about as you're coding. So you might have an idea, but you'll see as we go along. All right, so let's just hop right in. As we recall from yesterday, we know that this is a code cell. These are markdown cells. We can pick this run. Exciting. So we're going to run this anyway. So now what we're doing is we know that there are things that Python already knows, right? One of the things that it already has is a warnings module. Why are we yesterday, Monday? Okay, I'm just gonna, when I say yesterday, just know that I'm talking about Monday, okay? I'm just gonna keep saying yesterday, but just know that I'm talking about Monday. So Monday, we talked about how Python already knows things. This is one of the things that it knows about. And also we talked about, when we were looking at the code, that there are better ways to check and see the potential for downfall in our code. And so we are going to be looking at that just a tad bit today. So the main thrust, number one, will be talking about functions. Okay, so what are these functions? Yesterday, we actually saw functions, right? Because we created this function that would allow us to essentially create a dictionary and a list out of an email. And so what we saw about that function is that it had some inputs and then it gave us some outputs. So that is precisely what a function is. We can get some inputs, although we don't have to. We do some operation and then we can return some outputs if we want to. When you don't see functions returning outputs, usually that indicates something called side effects, meaning that the object is manipulated in memory. Okay, and so that just means that, if you're thinking about a memory address as a house, you would always go into the same house if you go to the same address. But if it doesn't return anything, like you can just be rearranging things in the house and be totally different in the house, even though it has the same exact location. And so that's what usually when functions don't return anything, that's what's going on. You're just manipulating and moving around the structure or doing some computation on this object in memory without returning something. So let's think about this very much in context, since we've already seen functions actually. So let's just think about this in context, okay? So we have been interacting with these generative AI models, right? Usually it is through going to some website and then we start interacting with it. And so let us think about if we were going to write a function to define this behavior, what would we need to do so? Okay, so let's talk about it. And again, feel free, put it in the chat, shout it out. I am happy to hear it all, okay? And there are no dumb answers. I have more dumb answers than anybody, so just saying. All right, so let's just begin by asking some questions that, again, if you feel like you're giving a dumb answer, totally okay. Dumb answers are so great for programming. So let's just start with some questions that we might ask ourselves if we want to write a function, okay? So what exactly does our chat function need to do? So when you go to ChatGPT, you do something and you get something. So what does our chat function need to do? What are your thoughts? Omar.
needs to take the person's chat, like what they say, and then put it, and then start responding to it. So we might need to get an input from the speaker so they can type into the program.
Okay, that sounds good. So it sounds like respond to the user based on their desires as communicated through the input. Okay, perfect. That sounds good. I think that's a great description. All right, so then what will we call this chat function? Is there a specific name that's sounding really good? Names? Thoughts? Don't be shy. I have my eye on this chat and I'm waiting for all the answers. Chat DPT. Interesting. Okay, other answers. Chatbot. Okay, yeah. Chatbot 3000. I'm obsessed. Yes. Other, it's Skynet. Love it. Chatty. Question from user. Do chat function. Oh my gosh, I love that chat function. I was so close to actually write only chats. Y'all are so funny. But these are great answers. So something interesting about functions is that they do something. So usually when we're going to name a function, it's going to be a verb. Some folks have given some great answers for the name of a class, which kind of defines an object or defines like the architecture of an object. But I'm liking this. Somebody said, oh my gosh, y'all are so funny. Do chat. I like do chat. Question from user is also good. Maybe answer question from user. That would also be really good. Yeah, I'm liking those. So let's go with, we're gonna call this one, let me see, do chat. I like do chat. I'm gonna call it like that though. Nice. So this is our function name, do chat, and it will respond to the user based on their desires as communicated through the input. Great. So what things are affecting how the chat behaves? What do you think? So this may be more of a question for people who may have already used like the API before. What are your thoughts? The arguments within the parameters of the code. Yes. And what might some examples of those be? Oh, interesting. So I'm just going to give some examples. User ID. So maybe if you don't have certain permissions, then you don't get a certain kind of answer. The input string. So the model itself is affected by the training data. But when we're just interacting with this already established model, that will be less of something that we'll need to take care of in our do chat. Excellent. Oh my gosh. All right. Previous chat context. Input language. Oh, so good. Mark, this is so good. Ooh, extra. Extra content. Oh my gosh. Output format. Oh, that's so good. Output. All right, all of these are really good. I just grabbed the ones that I saw first. Ooh, I'm actually going to also add, let's see, temperature, because that's super interesting. Okay, and you will also see that one again. Excellent answers. I love this chattiness. Okay, chattiness. Okay, anyways, so now someone, let me see. Look at this chat right quick. One of the first answers was really interesting because they said that the first thing that they thought of was input string, which is so interesting because actually when we interact with these models, like that's what we put in, like that's the main thing we have to put in to get a response. So I don't know, anybody think that maybe that should not be like the main input to this function? People kind of on board with that? That's sounding good. We're in agreement that that should be the main input. All right, no nays, love it. So we're going to go with input string. And the output of the chat is what is the output of this chat? So you say something to ChatGPT, Bing GPT, what happens? Beautiful. Output string. That sounds nice. I love it. That sounds good. There also could be other outputs, but we'll just go with this. Let's see. So, okay, so this is kind of a hard question. We can definitely remove this from parameters, or we could choose to, we'll talk about that, Carol. That's a great question. For chat behavior, we should define what the actual function would do. So in our last example that we saw on Monday, we saw that there were, string splittings, we were deciding on flags. If you have to describe what this function should be doing, what do you think that it should be doing? It should be doing what? We had to describe the innards. Ooh. Perfect. So someone said, ooh. So we could say maybe call the APIs of the Gen AI. And then more formally, we need to accept the user input, interpret it, pass through the model to get response, return response. That's sounding perfect. Okay, that sounds great. So by all of these things, we've actually created this function pretty much. Like what we've said is we need this thing to respond to the user based on what they're telling us. We have decided that the first thing or the main thing that we always need to have is the input, but we can also have these other things that will kind of change how the chat behaves, maybe what it will return, how it's going to digest previous context with input string, how it's going to utilize the extra content, maybe it'll switch languages, but for sure we need that input string. We also decided that the chat is going to be called do chat. That's the thing that's going to do all these things. And what we're going to get out is this output string. So then we need to define the function body, right? Which is this chat behavior. And essentially we need to get this user input. We need to maybe do some operations on it potentially, put it into the model or into the API to get the response and then return that response. So that's actually exactly what a function is, right? We already said that function name. So one, this is the syntax of what a function looks like in Python. So we have this def, which means we're about to define something. That's just a keyword that we use to indicate that we're defining something for Python. And then we have the function name that we chose. It'll probably be do chat. And then we have this main object that is required, and you will always want to put that first. So main chat object will be input string. And then let us actually remove this, like someone suggested. That's a great idea. And then we'll just strictly use these specifically as the chat input parameters. So essentially all these other things, maybe we want to require them, maybe we don't, but we can decide on what we actually want to do. Then we have this thing that's called a doc string that describes to the user how to use this function or what it is and what it does. Then we have like all the actual code that's going to do the thing that we needed to do. So this chat behavior in code, you would write whatever you need to do, and it would be about here. And then we said that we want to return these chat outputs. And we do that by using a return statement, and we return those things that we want to return. So the thing about this, again, this is some syntax. Everything that the function does is indented. So everything that this function should be doing, it has the indent. If you have something at the end of this that is not indented, essentially that will run after the function is defined. So only the things that are indented correspond to the things that the function actually does. So it's that time, people. Okay, but before we get there, we're going to have a quick question. Michael.
Yeah, I was just curious. Maybe this is not, I'm not too familiar with the Python, but why we need an object instead of they're all parameters?
That's a really interesting question. It's such a good question. So everything in Python is an object. So this could be chat input object parameters as well. This thing is just the first thing that is required. So this could say chat main parameters as well. Yeah, Spring is an object, like classes, objects, like everything is an object.
Yeah, I see that a lot of use like a self or something like that. I don't know. Is that typically I see like it used like pass as a self, right?
Interesting. Okay, hold that question for a second. It's such a good one. Okay, hold that question. We're gonna get to where you see self. Oh, such a good question. Okay, anyways. Yes, so this thing right here, this thing is really just a parameter. That would be like the input, some input string. We will get to self. Self is an object-oriented thing. All right, so now let's hop into some breakout rooms, okay? You are going to try, given what you know here, given what we've described here in English, you are going to try to generate this chat function yourself using whatever generative AI you so choose. Okay, and it's going to be interesting. And this is why I say it's going to be an interesting day, because we're going to be doing generation on our own a little bit, and we're just going to see how that goes. But use whatever generative AI that you like, but try to ensure that it's not just casually putting things in there that you don't actually need. So if it has some random definition in here that you don't actually need to use, then in that case, just remove that from the function. So we are making this chat function, but we are going to specifically use for our model a Hugging Face transformer. And the reason for that is that it doesn't require an API key. Usually it depends on how this chat is generated or how the function is generated, but you will not need an API key to use a Hugging Face transformer. So you can specifically say the model that I'll be using is a Hugging Face transformer. And then in the breakout room documents, go ahead and record that prompt. And then if you need to prompt it for more things like simplify this is unnecessary, or you find that things are necessary, you want to ask it what's unnecessary, go ahead and record those things as well. Also, like copy and paste it out of whatever generative AI that you're using, and make sure that the function is actually doing what you expect it to do. If you need a model name very specifically, you can use GPT-2 and just make sure that it is asking you for text or it uses text generation. And then if you have unnecessary code elements, just write them down. And then you will most likely get this warning that's going to come out. See if you can work with the generative AI to figure out how you can remove that. All right, fantastic. Let's see. Let's see. I'm going to stop sharing just right quick. Let's see, is anyone here currently?
Yep.
Oh, and would you mind creating those breakout rooms?
Yeah, they're ready whenever you are.
Perfect. Okay, so let's hop in. It'll be 10 minutes. And your goal is, again, to generate this function that acts as like a chat, and see how that goes. Try to make it simple. No just casual additional stuff. All right, let's hop on in.
This is really fascinating to see. Hey, Holly.
Hey, Jesse. Hey, guys.
Hello.
I'm actually on my cell phone. I'm having a hard time getting into a breakout room. So I'll
Okay.
just sit for a while until you come back in. So,
Okay. No,
Okay.
that's excellent.
Thank
Are you enjoying the workshop so far, Holly?
so far, I have to tell you that I have a lot of catch up to do because I've been traveling. So I missed the last 2 sessions.
Sure.
So so I can't really tell you much. It's just, I'm just super grateful to be doing this.
No, absolutely. And if you want to have some one-on-one time, just let us know, because be very happy to get you caught up. It'll be surprisingly, shockingly fast to get caught up, frankly.
That's great. That's my job. As soon as we get settled, we've got about another hour of driving, and then
Okay.
got several hours of homework today and tomorrow, and I'll be caught up hopefully. So thank you, Jesse.
Absolutely.
So I'll just you just ignore that I'm here. I'm gonna
And that's
mute.
fine. Yeah.
All right, so I just broadcasted 2 messages, one which is about some hints that can help, and then another one is just saying that if people need help, they can request assistance, and we'll go into the rooms. Should not be too rough, but I have seen where it does sometimes give answers that are, something.
Okay. Yeah.
Hmm.
And I'm going to be dropping out the last hour of this as well. I guess it's more office hours, because I'll be doing the VUSC thing. VUSC. Yeah. And Shara, you and I are going to meet with the dean together on Tuesday.
Okay. I am gonna run and go get some water right quick. I'll be right back. All right, folks, welcome back. Welcome back. How did it go? Quick thumbs up in the reactions if you were able to generate this function and it appeared to work. Oh, and we're not all back in here yet. So where is that? Quick thumbs up if you were able to write this function and it appeared to work in the reactions pane. Or did it not? Let's see. All right. Things are looking. Oh, red X. Thank you, person. Red X if it seemed like it wasn't maybe going so hot.
We got to the pad token ID error, but we didn't have enough time to fix it.
No, that's perfect. That is great. That's great. No, totally okay. That sounds absolutely fine. Would anyone be interested in pasting their code specifically in the chat? And we will give it a try, or we will comment on it, or we will think about it. Let's see. I'm going to share my screen again. All right, I'm just gonna pick. This is really exciting. All right, someone did an OpenAI one, and you can comment and tell us about that. But I'm going to, okay. Interesting. All right, let's look at this one. Oh, it is kind of hard to copy this. Let's look at some examples. Okay, so this is one of them. Did anyone get this? Anything that, or anyone else get something that looked like this? Okay, so this is good. Appears to be good. Let's see, let's give it a try. Did the person who pasted this in the chat, do you want to talk about it a little bit?
Yeah, I can talk about it.
Okay, tell us about it.
So initially it gave me that same code. I basically asked it the exact prompt that was in the instructions, and I added that the function should prompt the user for input because it wasn't initially doing that. And then I was getting an error because I didn't actually have, like, I had to add that first line. The one that installs, the one that says install
Pip install.
transformers. Yeah. And then I asked it some questions, and I chose GPT-2 when it prompted me to choose which model. And then I asked it how tall the Empire State Building was, like, as a test, and it didn't really seem to understand my question. And then I also got that pad token ID type of response.
Gotcha. It's interesting that this is able to run with GPT-2 sometimes. So this is something interesting. So I will comment on this example. This example in general talks about get chat, but what this is actually asking for is completion would be more accurate. So the way that we interact with ChatGPT and the way that we interact with GPT-4, it's conversational. We can like ask them questions, give them some context, and then we'll answer. These particular models are more generative. This one is a little bit better because it's text to text generation. So this is like in the weeds. But if you're going to use Hugging Face transformers, like what GPT-2 is, I think it's this one. This is the one that should do it for you. But it will only just continue to generate. In the way that we talked about the first week, where we're just like predicting the next word. Nothing that is reinforcement learning from human feedback, nothing that is instruction fine-tuning. But yeah, that makes complete sense. That makes complete sense. All right, I'm seeing some other ones, and interesting. So I also have seen this one. I wish I could just share this. Something I do want to point out from, I think Jack, that is one of the pieces that I intentionally left out, is this part. When you are in Google Colab, you will almost certainly have to always pip install any packages that are a little bit unusual, or I mean, you wouldn't expect to be built in. Generally, if you look at like the thing that you're importing and it says import transformers cannot be resolved, really what that means is, hey, I don't know what package you're talking about. Like, give me some, like, help me out. And usually that means you need to actually install it into the environment. So that's how you can do this. And I use this % capture if I'm pretty sure that it's going to run. Well, I'm certain that it's going to run and not generate errors. And this just makes it so that you don't see a lot of output. So the second one here is really interesting. I like that there were some exception handling added. For the actual implementation, this is a little bit of a higher level of implementation, especially compared to the previous one where you get the response using essentially a single line, which is this. But very interesting. So let's go into the design, another answer. So I am gonna steal this one. And do know we do have to pip install this. So if you haven't pip installed, you're definitely going to want to do that. Actually, let's put this all in one spot. Sorry, people. We're going to get there. That's going to be too much. We'll just get there. Fix that one later. So, okay, so we've pip installed that. We have imported pipeline from transformers. That gives us access to this thing right here. So I am essentially going to copy and paste this thing. We'll see how it goes. So this is interesting. I love this addition. So this is prompting the user. This is actually an example of how you would use this get chat functionality that you wrote. So I love that you did that. You can also just like directly pass things in. So let's take a look at that. So copy this one. Let's see, I'm liking that. Model name, input text. So this is interesting that I generated this in this order. I would personally suggest, as we talked about, so we want the main thing to go first. So generally we would want the input text to come first, and then we would want the model name. Something interesting about this, that when you use the API, is that if you don't pass in a model name or you pass in none, it'll just kind of make one up. So not make one up, it'll use the default one that it uses. And so here, I think that's pretty much, yeah, I think that's looking good. Question, Michael.
Yeah, I think I see different ways to define to create the model object.
Mhm.
One uses the pipeline, but I also see they're using like the code I have been seeing, like GPT-2 header model thing. What's the difference there, I guess?
This one? Like this?
Yeah.
And like this?
I mean,
Yeah.
look exactly like, you know, you have different ways to create the model, right? One is use the pipeline. One is using auto model for, you know, causal LLM, you know what? Sounds like there are many different ways of doing it.
Absolutely. It just depends on what one is after. So in Hugging Face, there is an abstraction called pipeline. And instead of having to create this model, then the tokenizer, then when you want to get something encoded, decoded, generate, instead of having to do all that, you have this abstraction called pipeline, which just does all of it. And so what you do is you pass in an input, and you get an output. That's essentially what it is.
Oh, so are you saying the pipeline is actually to wrap all this lines of code that you actually highlighted?
Yes. And these.
And this. Oh my, okay. Got it.
And then not only that, but it actually wraps all of the different like types of models. So there's audio classification models, there's text-to-text generation models, there are multimodal models. it also allows you to just use that. It's like one singular interface for a lot of different functionality.
Wow, this is pretty. Thank you so much. That's a great.
Hugging Face is exciting, and we'll talk more about APIs as we go along. So let's see, we can do this. This is looking good. Let's run this. So we have this get chat input text. This is something that we, as a side note, I saw some questions about the order of these parameters. One, most technical, so with functions, you can actually pass in nothing. It just means that everything your function needs to do has to be defined in here, or globally, but mostly in here. And it can also return a response. But if you have something that comes first and is required, you should put it first. And I think you're required to put it first. So we ran this. Let's see how we can use it. So one, I love this prompting. So this function, if you call prompt user, you'll need to put in an input, and then that will populate this. You'll need to get the input text, which will populate this, and then you actually call the function. We're just gonna borrow this directly. And we're gonna try that. So let's see, get chat model name. Let's just, oh, wait. Oh, we flipped it. So one, we flipped this in this definition. So we need to flip it here. We're gonna put the text first. And let me see, what is some good text? The dog was, I don't know, I always have these examples. The dog was super cute and ate 30 because, I don't know. And then the model name, we're gonna do GPT-2. Let's see how it goes. And so you could see here when we ran this, right? We didn't like see anything, nothing happened. But what happened was that we defined this again in the kernel. So we got some error. It's fighting us. Let's see. Let's see. Interesting. It says GPT-2 is not the blah, 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 blah. Interesting. Unexpected. 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 Let me see where I could be going wrong. Thoughts? Anyone? Thoughts? This is like super unexpected. Like, we haven't seen this in a long time. Actually, I've never seen this. Even when I wrote this literally yesterday.
So Shiro,
Oh,
like
I just
you hear me, Shiro?
Yes.
I mean, I just reran code that I ran while I was the code ran no problem when I was in my breakout room, and now it's giving me the same thing. Like, I don't know if that's this is like a more global thing, like we're not reaching the Hugging Face right now.
Yeah, maybe we're just in a bad way with Hugging Face. It could be. The first thing that happened, I mean, Jesse, thank you for saying that. Or Jesse? Yeah, I think that was Jesse, right? Thank you for saying that, because this is, I've just never seen anything like that before. Maybe we can give it a second. This should run. Yeah, maybe it's us. We're breaking Hugging Face. I'm just kidding. I don't think so. But yes, interesting. Maybe. So I can work on this. I love how I just keep running it, like hoping for something different. Sometimes it's like that. We're working with servers because they start acting correctly. But essentially what you will see when this runs is that it's downloading a model. And then when it gets that model, it runs it through this pipeline. But it has the same behavior for this as well. So, oh, no, we made it. Okay, so now we're downloading. Maybe the server kind of came back to itself. This is a little bit slower than what we normally see. If someone has a little second to check on Hugging Face, if they have any tweets or anything about their service currently, just let me know, because this is going to be quite something. But we can give this a try. Yeah, so even this is taking a very like long sort of time when it usually doesn't take that long. Maybe we're making it. Let's see. Regardless, we see that we can input the string as desired. That's interesting. We can input the string as desired, and then we can input the model name. The string goes here, it utilizes the pipeline, which creates the model for text-to-text generation. The model name that we pass in here, GPT-2, is is passed in, and then we can see here is the model then uses the pipeline functionality to get a response based on the input text, and we get that response. That response comes out, and then we print it here. Something to keep in mind, though, is that this name is the same. So response here is response here. And the only reason, and so like if we wanted to name this something else like responses or answer or something like that, it would be absolutely completely fine. This is just like a dummy placeholder or a name thing for us as humans to be able to understand that corresponds to the thing that is output. All right, Sean, awesome. Thank you for looking into that. He said that Huggy Face was down for 10 minutes. Luckily, it was the 10 minutes that we were talking. So that's really good. So in the meantime, we're waiting for Huggy Face to just kind of, collect itself. Let us talk about something that people have addressing, okay? So let's see. We have been talking at length sort of about these parameters, right? And so now we're going to actually investigate those parameters. So let's see. We had lots of different ideas. Sorry, let me get back. Lots of different ideas for input parameters. So user ID, blah, 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 blah. We have lots of them here. What usually is the case is that you can use a default for most of them. And then if the user wants to change them, then you can have the user, give the user a way to change them. So let's say that we decided that we want to add 2 parameters. One of them is just device. So device is usually a parameter that allows you to select whether you're going to be on the CPU or the GPU. And then this second parameter is going to, decide how we want to return the response. So here, and we struggled. We struggled to get that thing to download, but we made it. Here you can see the actual input that we had. The dog was super cute and ate hurriedly because the dog was super cute and ate hurriedly because, and it just finishes that sentence. The time the kitten was getting ready to run was when he really needed to look at something. Funny. So we got that output, and then we got some more output. And so now what we're going to do is we're going to actually modify this output. Return full text basically means if return full text is true, it means that you actually want to include this prompt in your answer. And you can see that that's what we did here. We also maybe just want to complete the sentence. And so we want to be able to set that to false. So let's take a look at how we can implement this. So we actually already have it implemented. We may have just asked for those things to ChatGPT. And so let's look at it. Let's experiment with it. Number one, we see that we have something here. So before we had this as input text, right? And so that's the first thing that we pass in. And then we have that same parameter for model name, right? Except now we've added some more syntax where we have it equal to none. So what does that mean? By default, you're going to be passing in text. If you pass in nothing for model name, it'll just use none. The same thing for device. If you pass in nothing for device, it'll just use -1. If you pass nothing in for return full text, it'll just use false. So some things you don't have to define. If you must pass in text because you see it doesn't have a default. If you only pass in device, and so say you want to set it to 0 or 1 or 2 or something, you can do that. And then these 2 will then use the defaults. So let's see. We see that we're using the same functionality that we had before. Hopefully we're going to make it again, where we're using the pipeline, the text generation pipeline. We're going to pass in GPT-2. We're going to pass in the device of interest, and it helped us here with the pad token ID by saying that we should set model quard so that we pass in this dictionary that defines this thing. If you don't know what, let's see. Oh, nope, we made it past. Awesome. Yeah, this error, it's just annoying to look at. And so we can have, this is the way that maybe your generative AI told you how to fix it. So let's run this one. Okay, we just copied that from here. And now let's experiment around with it. So one, we see this expected sort of input. We know that we always have to pass in text. So here is the text. Let's pass it in and see how that runs. We might have a rough time now. All right, and so we did not pass in GPT-2, right? And so then it just used the model name as none. So when we pass this in, model was set to be none. And when that happens, Hugging Face, which is where the pipeline comes from, or transformers, same, it just chooses one. And so it says no model was applied, so I'm going to default to my default. And so we're using this one, and here we go. We're going to make it. And so we'll just see how this one is working. Let's try another one while this one is running. Maybe what we want to understand is, so one, this runs and we get an answer. And the answer is, the cat ran down the hall, it was crazy. And then it came up to me that it's like the beginning of one of those cats fights, the cat and dog, blah, 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 blah. So it did finish it for us and it did run. Excellent. So now we know we can call this function with only the input text as it is required. Let's see if we can run it with nothing. So let's just run it like this. Some functions that you call will look like this, but not this one. Why? Because it says it is missing the one required positional argument, which is text. And that is that first one that does not have a default. So then we can see, we might wonder, like, what if I just define these things in order as I think of them, as opposed to how this is defined? Like, what if I, instead of putting model name, then device, do device, then model name? Well, let's take a look. First, we'll confirm that, this order works. So this is input, right? This is the input text. We've set this parameter to be true, and the model name is GPT-2. Actually, no, that's out of order. So this one is now last. Let's see if that runs. Oh, and do keep in mind, so this is an interesting moment where we're seeing that depending on how we define our function, okay, it can take a long time or a short time. So consider that this thing right here, every single time we run this, it has to be like created, right? And so it would actually be better if we didn't have this in the function, but we had it outside of the function. And so that's one of those considerations that you learn when you get into situations like this. If something takes a long time to generate, you don't want to be calling it over and over and over. You want to see if there's a way that you can kind of streamline it. So coming back to whether the order matters, we have seen that not so much, it doesn't. So long as we have this input first, if it is positional, that means we have called it in a positional way, meaning that we don't have text equals, blah, 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 blah. That means that we can call these things out of order. Let's see what happens if we can call the required inputs out of order. Let's see, what if we, I don't know, put this model name GPT-2 first. Let's see if we can run that one. Unexcited about that one. And what is the error that we get? The positional argument follows keyword argument. That sounds very cryptic, but think about it. So this thing here that you've passed in, it has no keyword associated with it, right? So you can only assume that it actually is supposed to, you actually have no idea what it is from the view of the model, right? And so because of that, when you have a required input like that, in this form that we're calling it, with no keyword, it has to go first. So let's see an example of that. Let's try this one again. And now we see that when we name it, so we've called them all in that keyword sort of way, that we're able to do that successfully. So essentially, if you have a required input and you're going to use it in a positional way, meaning that you're not going to be using like this text equals all the time, that means that it has to go first. And if you have, and however many are positional, let's say that you decide to have model name also be required. Like this That means whenever you use this function, if you pass things in without their keyword sort of name, that means you must pass in the text first, followed by the model name, and then the order of these won't matter, or even if you include them. How is that? Feeling pretty confident? All right, excellent. We're getting such, what? The dog might have rolled in the garbages this morning, but the guy who caught the dog could have been eating it too. That's, thank you, GPT-2. Luckily, we're on GPT 3.5 and GPT-4. All right, let's see. So we also have already talked about how we want to be able to catch unwanted behavior. So someone gave an example above. Sorry, I'm doing some scrolling. I'm going to try to do it a little bit slowly so it's not making people sick. We talked about how you might want to be able to catch errors and like say something to people about the error that they're running into. For example, the errors that we just saw, kind of helpful. And so we want to be able to catch those or at least say something to people if we want our code to keep on running. Okay, so this right here is an example of what error handling looks like. So you try the code that you want to run, and then if it runs into an exception, it'll throw an exception or raise an exception, and then we catch it and like move on if we can. We will talk more about that at length, but we can look at something which is interesting. And so this, what we are doing here is that I'm sure you noticed that this has a lot to say to us when we're just trying to look at this. Like it is a lot, and there are warnings, and these are warnings about things that we actually can't really help right now. And so we might just want to suppress those warnings, right? Like it's nice that they've given them to them, but we just like, it's a bit much to look at. So again, Python has a warnings like package, just like it's something that Python knows. And so we can use a simple filter and we can call get chat again. And what this does is going to ignore all our warnings. It's going to ignore them. And then we will pass in exactly what we want. And we will get some results. So a quick question though, have you seen this with thing before? And if so, where have you seen it? Perfect, opening a file. So what is this with thing? So when you see with, usually it means that you're about to be using a context manager. It means that in this very limited scope, certain things are going to apply. But when you come out of this limited scope, then it's going to go back to the normal settings. When it comes to opening and closing files, that context manager is taking care of opening the file and closing the file. Most people did not have like a f.close there. And that is because that context manager is taking care of all those things. Here, we generally want warnings, right? Because we just don't want warnings from that function that we've written. So we use this context manager, ignore warnings, and then within this context manager where we have suppressed warnings, we actually call our function. And so that helps us to not be seeing all those functions, all those warnings when we're calling this. So you can see here, we are without the warnings that we saw above. So that's really nice. So we have learned some things today. One, if Hugging Face goes down, we'll get a certain kind of error and we can feel confident that our code is probably, it might be correct, but it's not our code that is causing that particular error. We also learned about functions. We learned a lot about them, that they have names, they do things. They can accept inputs, but they don't have to. They can return outputs, but they don't have to. They also have a set of arguments that you pass in. If you pass in arguments that aren't defined by keywords, those are positional arguments, and they must come first. And the way that you pass those arguments in must be in the order that they're defined in the function. And then finally, we have these keyword arguments. They work great as defaults. And so if you don't choose to pass in definitions for those keywords, for those parameters that are optional, then they just use the defaults, and it's pretty exciting. Also, what we have learned is that we can write code directly that will work pretty well using our ChatGPT GPT model. And finally, sorry, I'm scrolling again. Finally, we have learned that when these models generate this code and it says something like this, that you're going to be using a certain package, it is a high likelihood that you will need to pip install it. before you actually use this code in Google Colab. Yes. So now I think we've made it through functions. Let's take a quick 5-6 minute break and let's come back at 10:10 and be ready because we are about to jump into object-oriented programming. So hang in there with me. It's going to be awesome. Return at 10:10. All right, folks, welcome back. Welcome back. Welcome back. Feel as if that's a song. All right, I am going to go ahead and share my screen. And let us continue. So before we said that we are writing this chat function, right, as a function. And this is the function that we essentially had. I'm grateful for someone who wrote the function with OpenAI because it helps to show something. So for Hugging Face, our function looks like this. And for OpenAI, our function looks a little different, right? Because one, you need this API key. Two, we call this function, or we call the model completely differently. So that's two that look really, really different. What if there are models from other places? What if we want to give our users of our platforms access to a smorgasbord of different functions? Are you going to call it do chat OpenAI, do chat Hugging Face? And then you're going to have to manage all of these sort of free variables like model name and then API key? Or would it be better to instead create individualized, encapsulated classes which correspond to the model that you're using? Let's see. You don't have that an answer now, but let's see. So we already saw functions, and we've actually already saw some methods. Strictly speaking, your method is going to be a function, but it's going to apply to a specific class. What does that mean? So briefly, let's just take a toy example. So let's decide that we are going to take this approach where instead of using a function, we are instead going to use a class. So we're going to have a class for every model that we want to use. A class means that we are going to have it's like a blueprint. It's like a blueprint of what kind of functionality that you want your model to do. So how you interact with it, what you can, how it behaves. So those are going to be your methods. So let's say you have an oven. What do you do with an oven? Well, you need to turn it on. Often you need to preheat. You need to set it to bake or broil or whatever have you. Maybe you need to turn on the light. Those are things that your class oven needs to be able to define what it means how to do. Also, if other people want to interact with your class oven, they need to know what they can do with this class oven. Also, when we have a class, not only does it define the way that we interact with it, it defines things about it. So maybe you have an oven that's black, or maybe it's white, or it's gray. Maybe you have, I don't know, a convectional oven. Maybe it can have these different wattages, or maybe it has a different manufacturer. All these things can define essentially any oven, right? And so that is why our class definition is truly just a blueprint for the objects that we want to create that have that specific class. Okay. So let us take a more foundational, or like a little bit of a better example that's applicable to us. So as we said before, okay, we have decided that we are not going to view the chat functionality as a function. We're going to define it as a class, because once we define something as a class and create an instance of it, it has its own definitions for the different attributes, and it has the methods of which you can interact with it. This object is encapsulated, meaning that everything that all of its attributes stored inside, if you manipulate the object, you can store its state as well, okay? So once you, for example, initialize this object, so you saw like the pipeline, once you've set up that pipeline that first time, the state is remembered. So you can save the state of that model so that when you go and you try to do your chat over and over again, you don't have to set it up again. And so this is one of the really nice things about classes. So let's try to figure out, okay? Let's work together to define our classes. So let's think about specifically an OpenAI model and the Hugging Face model that we just saw, right? So with OpenAI, we're kind of experienced with that. We know sort of what it needs, like what it needs to be able to do. So we have an object of class OpenAI. We understand what it needs to do. When we have an object of class Hugging Face model, we know what it needs to do. And so if you had to summarize or state what functionality, what main functionality or what side functionality does each model type need to do, what would you say that that functionality is? Would you say that that functionality is actually essentially the function that we just wrote, get chat? It needs to take in some chat stuff and then it needs to output its response, right? So then essentially what we want is we need it to do this like get chat sort of functionality. Both of them need to do this. Let's see. Do we think that the functionality or the behavior of these models will differ for get chat for the Hugging Face model versus the OpenAI model? Have we seen that the actual implementation of sending the information to Hugging Face versus sending the information to OpenAI will be different? Let's think about it. So for Hugging Face transformers, let's call this Hugging Face model, get chat had to do something like model at output. And then that's how we got the output there. And what we saw with OpenAI, that example that someone sent above, it looks more like OpenAI.completions.create, blah, 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 blah. So when we call this get chat functionality for Hugging Face models, it will just pass in the, input. It will just pass in the input to a pre-existing model that we have created in our class. For when we call get chat with OpenAI model, it needs to call this function or this method from OpenAI. So when we write get chat for Hugging Face model, we write get chat for OpenAI model. They will be called the same thing. They will essentially be trying to tackle the same task, but the underlying implementation of this will look different. Let's see, what functionality is left best performed one time? So we just saw how we had to call this Hugging Face model and create it and download it essentially every time. We'd have to download every time, but we had to, it was a long process of getting this model instantiated or bringing it into existence or into our kernel. Things that take a long time. These are things that are what is left best performed one time. So let's see, for Hugging Face model, I think we said creation of the pipeline model. And then for OpenAI, we might not want to always be passing in some API key. So maybe we just want to set the API key one time. Let's see then. What characteristics, so now that we have this class and this object that is going to encapsulate everything about our OpenAI model, let's see, or our Hugging Face model, what kind of information should we store about them? It's a hard question to answer a little bit, but for sure what we want, based on what we said above, is that once that pipeline / model was created the first time, we never want to create that again. So we want to store that model in our object. So we want to store the pipeline. For OpenAI, maybe it would be nice to store the API. So we've seen that the underlying implementation of get chat is different, even though they both must get chat, right? Otherwise, we have no way to interact with them. We've also seen that there is probably some model name that we need to reference both of them with, right? So when you pass in something, when you try to create a transformer from Hugging Face, you have to select the model name. We passed in GPT-2. For OpenAI, you need to pass in the name of the model that you want to use. Maybe it's DaVinci, maybe it's GPT 3.5 Turbo. So for sure, both models need to implement get chat functionality, and both need model names. Both need some sort of initialization. And that's what we saw before. Maybe the thing that is performed one time, maybe that's the initialization that we need to do. Maybe these things that we need to store, maybe that can be done during the initialization. But in general, these are the things that we need to have in common, okay? So it's kind of abstract at the moment, given that maybe transformers and OpenAI API are a little bit unfamiliar, as is the notion of classes. But this is what a class looks like in terms of syntax. So if you wanted to create a class, this is what it would look like. And it would look a lot kind of like a function definition, right? So we have this def, which indicates to Python that we're about to define something. We'll have a class name. Usually that will be followed directly by the colon, okay? Because that is what we're going to be defining in here. If you have something that has these parentheses and it has something inside, that means that you have a class that is inheriting all its functionality or much of its functionality from another class, okay? So don't worry about that, but you can if you want to. So here we have a class description like normal. We love doc strings. And then we have this thing that we want to define usually for classes, which is called this init function. So when you first create your class, this is the thing that will be called by default. Interesting. If it calls it one time upon initialization, maybe those are good places to do the setup. And so here, this is where we see self, okay? So we see, and why is that? And it is because of this notion of encapsulation. These tasks that we do are usually relevant to things that we have stored inside ourselves. So if we were classes. So for example, if we stored the API key, then we could use something to update the API key. If we stored the model, then we can always call the model. And that's why we first reference self, because it refers to either the class or it refers to the object that we have created based on the class. So here you have some initialization, you might have some selfness, you might set something as your, from your inputs, you might do functions of them, and you might choose to save some of the values that you pass in or that you create using this self attribute. So as your model continues to exist, you will always have these things stored. Seems like self.model would be nice. If we could just have pipeline, like make a pipeline self.model, would be super nice. Then we can just have other methods, right? So it doesn't have to be init. This one, for example, get chat, sounds awesome. And so we can also pass in other parameters. So again, this thing right here is looking a lot like a function. It is a function, it just has self, and we call it a method because it's related specifically to the class. So this is the kind of structure that you should expect to see with the class. So now we're just gonna pop into a breakout room right quick. And we are going to say, for example, that we said all of this essentially to OpenAI or to our generative AI. If you want to know exactly what was said to generate this code, it's actually down here somewhere here. It was a little bit iterative, but that's okay. And so here you see something that is going to be a little bit familiar if you kind of close one eye and squint at it. This here, that looks like a class with an init method and a function or a method. This looks like another class, again with an init and with this get chat. This looks like another class, again with an init and a get chat. This is an OpenAI, and so this is looking a lot like the OpenAI call that was pasted into the chat just then. This thing right here is looking a lot like that transformers pipeline thing. This is interesting the way they put it. Anyways, this pipeline that we just created, right? We just saw this. And here now we have this self.model thing, which is really nice. So y'all are going to go into a breakout room, okay? And so we can see that this was created, but now what we want to know is how these aspects are reflecting the things that we asked for. So in your breakout rooms, you're going to answer these questions. 10 minutes. And these are already pasted in your breakout room documents. So so this is just overall. This wasn't a previous question that we had, but you're just going to want to be able to explain what these three, what is this that we're looking at, even though we just kind of did it a little bit. If you run into issue, please feel free to click these little drop downs. I do want you to maybe, think about what prompts that you would use to begin with and write them into your breakout documents. But if you get a little bit stuck or it's not making any sense, please feel free to just take a look at those. If we want to understand, for example, what functionality each model type needs to perform, and again, that's a question that we had up here. This one. We said it's get chat. Now we want to know essentially how that manifests in this code. So maybe the prompt that we would use is, do each of the classes perform all of the same general functions? And so we have different prompts kind of as examples for any of these questions that you need, that we're trying to answer based on the code. And so what this will do is that it will explain a little bit more about what this object-oriented programming is and what these classes are and what the whole goal of this is. So let us go ahead and hop into some breakout rooms for 10 minutes and make sure to fill out your breakout room documents. I would love to know your initial thoughts in terms of creating prompts here about how you would ask these questions or get this information from your generative AI model if you put in all of this code and ask the questions about it.
Can I please be punted in whoever was in 15 on Monday?
Do you potentially remember who that was? Because if you don't have a name pre-pended, you're just randomly put into one.
Richard Davis was a part of the members.
Okay.
Context. Thank you.
VJ, do you need to be put into a room? Ah, great. Imong, if you don't want to put him someplace.
Yep. Raymond, I don't see him here today. Do you remember anyone else? You're muted.
That apparently was resplit, but I'm gonna hop in 12. A couple of people from last time are there. Thank you.
Sounds good.
Yeah, we might be able to predefine the breakout rooms, but I don't know if it's worth it with the number of people coming and going,
Yeah.
And I think the faculty appreciate having their own room. Not all the faculty are, but Oh. Did you have a, did somebody have a good graphic for LangChain? That you could share? Iman, can you share me you can Slack it to me maybe?
Sure. I've just found them. There's this guy on Twitter who seems
fine.
to be sharing some really good graphics. He's like breaking down LangChain into its components.
All right, folks, welcome back. Welcome back. Let's see. I am so curious about what you found. Would anyone like to share very briefly? Especially if you were able to get to that summary statement.
And the rest of folks just came in.
Oh, sorry. Overly excited. If you know me, you know I'm just like, I love coding, like a little too much maybe. Let's see. Welcome back, folks. And thank you for letting me know about that, Jesse. Okay, so would anyone like to share their basic findings about classes? Anything that was particularly notable, anything that were advantages as compared to the functions? Any thoughts? Omar.
For a class, you can make a super class and then have an inheritance to a subclass, which would make everything easier because rather than just having one class kind of like a function where you put everything together, you can instead make a super class and then make a subclass, then call the subclass instead of having to write everything again.
Yes, that is a really great point from a maintainability standpoint with code. Often if you have concepts or something like an object that would be better described in a hierarchy, it makes a lot of sense to write all of the common functionality in that base class, or either the common functionality in terms of what you should always be able to do with each and every one of the classes that inherit from this base class, and define like the attributes that each and every class should have. But you don't really have to write them again. You just write what's different in the classes. Awesome. Any other thoughts? What are your thoughts? Oh, go ahead.
We had a quick question that came up during our session about like the term method versus function. Maybe you could just sort of like quickly clarify, because we've seen the terms kind of used interchangeably, but should we think of them as separate or different things?
No, the words are used interchangeably, but some people will be sticklers about what a method is versus what a function is. And if you hear the term method, it just means like a function that applies to a specific class. So if you think about if you had a class that was like cat and a class that was dog, you would have a method in the class cat that is like do meow, but you would not have that method in the dog class. But you could have a function that is just outside of both of those things, that is make sound. And then that thing that's outside of both of those, not related to a class, like that must be called a function because it's just not a method. Usually methods are going to be associated directly with the class. Is that helpful?
I think so, yeah. Yeah, thank you.
All right, so that is sounding really good. The point of this is really not to overly understand this and understand inheritance and polymorphism. It's literally it's like a whole class, but to understand how we use them. So I'm going to share my screen right quick. I could never just by default hit the right one. I think it's this one. Yeah, there we go. So now let's talk about how we use them, right? Because as we talked about before, we have this def sort of statement, right? All we have is, it just puts it kind of in memory. Like it doesn't actually execute anything. So one, we can scroll down a little bit. Let's capture this. So now we're keep installing OpenAI because we don't have that installed yet. And you can see here that we're about to import it. So we're going to run that one and run this one. All right. And so now that we've run all this, you didn't see anything. There was no output. And that is because, again, we have just defined that in. So now how are we going to use this? Well, let's take a look. So one, what we could do is create an instance of the class. So again, the class is literally just the blueprint. Once you decide to instantiate it or create an object, those two terms are meaning the same thing, it means you create one of them. So in other words, there's some, I don't know, awesome engineer over at Kenmore who has all the blueprint schematics and designs for an oven. Once it comes off of, I don't know, the production line, that is an object because it has been instantiated with material. And then once we get this particular object, then it has another attribute added to it that maybe we add, which is that it is our particular object, right? So now what we're doing is we're creating individual instances of these things. So let's take a look at how we do that. So maybe what we want to do is call this thing LLM. We want to create an object called LLM, and we want it to be of class HF model. And we see in this init for HF model here that all we actually need to do is pass in the model name, and it's going to be used like this. So let's just do GPT-2 again. And then after that is created, we will just have the model that we want to be able to use it. So then we would do LLM and we would call the method that we wrote, right? LLM.getChat. And this will apply specifically to something of the class HF model, right? So getChat, because we are applying it to this LLM, which is an instance of HF model. Okay, so we're going to get chat. What do we need to pass into that? Let's see. Looks like we're passing in some string, which is question. So we called it question, but it's really not that. We'll just pass in something. I ran over friends. Oh, nope. To my friend and said, and then let's see how this one goes. So we'll run that. So you can see here, we're using the name of the class and we're passing in any initialization that's required, like this, okay, but not for this class. We get an object out that is of type HF model. That means whatever is defined by HF model, we can use those functions associated with it, and we have access. We can sometimes use some of the attributes that are associated with it. So if we really wanted to access this dot model right here as this pipeline, we could do that. Not only that, but because we inherited from this AI model, that means we have access to the things that are implemented in AI model as well. So here we can see that we can call the model like this and use these classes. So now we're just going to casually run these cells. And so what we will do is create a package. So there's a difference between this and then a package. And what we created is this, which is our package. It's called our LangChain, right? There's nothing like awesome about that. It's literally just an organization of folders and with some inits in it. And here we can see we created this Python file from literally our class. Like this is literally what is there, except for one little thing. Okay, a few little things, but a main thing, which is that you remember how we had get chat, right? That is actually the whole function of what we're trying to do. Like that's the main point of what we're trying to do, right? So it would really be nice if we could just call it sort of with the name of our object that we created. So if we look here at OpenAI model, what we can do is define these dunder methods. When you see a double underscore, that's something called a dunder method. It has to do with the underlying functionality of Python, but essentially it gives you access to this built-in functionality of Python that's really nice. So for example, we have this get chat function. Instead, we could just have the same function, but use this dunder method from Python so we can call it with the name of the object. Let's see what that means. So we were here. So now we can do like we would normally do, right? Hopefully. And we would just import the package as normal because it's our package. So what we're going to do is from our LangChain, that's the name of our package. We have a module, which is LLMs. And what are we trying to import? That's right, HF model. Let's say we're trying to use that. You saw HF model before, it's literally the same one. The difference here is that we've just packaged it up. We've packaged it up in a package called our LangChain, and maybe we just defined some model, which is, or some module, which is LLMs. So we run that, wonderful import. So now it's kind of gonna be looking like the same exact thing, right? We had LLM, HF model, same exact code, LLM equals HF model, GPT-2, run that one. The difference now being, we don't have to do this .get chat thing. We just call it directly LLM. I ran over to my friend and said, okay, so let us look at this. Look at this really, really hard right now. So what we did is we just created this package, again, an organization of just folders, but we have this module, which will be LLMs. Maybe we have another module, which is, I don't know, agents. Maybe we have another one, which is chats. And in each of these, we just have the functionality that we want to implement, right? And so when we are doing this from our LangChain, the name of the package, .llms, this is the module name because it has like other Python files in here. We import exactly what it is that we want, that class that we just created. Then we use the class as normal and we initialize it as normal. But because we have defined that dunder method for call, we can just call the functionality of the model like this. So look at that real hard. Keep it in mind for just a second. Let it be burned onto your brain. Okay, now we're going to switch over to LangChain documentation. Okay, so
I guess that's actually where my mind disconnect a little bit. How does that, when you call that class, not class, the
object.
Object, how does it know to call the call? And
So
because this is very, yeah, go ahead.
This is the functionality of Python, and that's a built-in method. That dunder
Okay.
method is something that Python defines. And so that is the method that you use when you want to implement your code that way.
So when you define object like this, it will automatically call the __ call method.
Mm-hmm.
Okay.
It's exciting, isn't it? I love it. So then let's go and look at LangChain. You can just like Google it. I guess I can drop this in the chat. And this is just a briefest of brief introductions because Miranda and Umang are going to talk about this at length. But this is so you can kind of see the application area. So one, we might get here, we might go to the quick start guide. All right, so we have done whatever we needed to do already. Now we're going to try to get predictions from a language model. Okay, wow, this is looking really familiar. So from what we had before was our LangChain.llms import HF model, so OpenAI. This is looking really similar to what we just had, right? Package, module, import the thing that you want. Then we define the LLM, right? So this is some class, and we're initializing it with these parameters. For us, we had a model name, got the LLM. Now we're going to use it and get a prediction. LLM, and you pass in the text and you get an answer. So when you are looking at these APIs, and this is like a standard use, when you look at them, do know that you know what you're looking at. Like it may look like sort of crazy and the words may be different and a bunch of symbols, but we've literally made a package that looks almost exactly like this. We imported for some package. This is one of the modules in that package, and we imported something specific from that. And then we created an object of that by using the initialization parameters. And then because we had that call method defined, on that object, we can just pass in the text to do whatever we need to do. So you will see this pattern just over and over and over and over again. So from import, initialize that, maybe do something with it. This is some method that we saw, right? That is applied to the prompt. You know what you're looking at. Let's look even more. From package module, import something. Package module, import something. Use that something else. Now we have another module, and this is specifically what we're importing. Now we're going to use it. Initialization object. You're a pro. You're a pro already. Okay. When you look at these things, you will see it. That is the model. You will see it over and over and over again. Okay, so rolling back, I know we have 9 minutes left, but just to hammer this down, again, what we have is something, so our LangChain here or LangChain, it is a package or a library. Usually those are used synonymously. And what they tend to have is a lot of sub modules that implement some functionality. And so if we have like a kitchen package, for example, we might have this module that's appliances where we define classes that are related to ovens or microwave ovens or dishwasher. We might have another module which has information about cookware. And so we have classes, I don't know, pots, pans, cauldron. Wow. And then we might have another package. So, or another module, okay? So then let us look then at what that looks like for LangChain. So LangChain is open source, right? So we can look at it with our eyes when we want to see it. So one, let us look at the modules, right? LLMs, that seems like a module that we just created. Let's look at it. Oh my gosh, so they do something a little bit different, which is that they separate all of their different modules into these Python files, right? Oh my gosh, it seems like, oh my gosh, just use those, right? Let's take a look. So we have some functions that we define because that helps us a lot, right? Same functions. Oh my gosh, it seems we know what that is, right? There's some OpenAI model and we inherit it from some other LLM. It's so exciting. So we're gonna look some more. Oh my gosh. So we're looking and it's okay. Like this is something that is familiar to you. You have just done it. You have just written it. We also see Hugging Face. And so you even see the pipeline. This is something that is familiar to you, okay? So all of these things are just defined in this module, which is part of this package. Here are other modules that you can use. They also have, let's see, might be interesting. I don't know, chat models. We have these chat models that we may have available to us. We'll have to see how to use them, okay? So from LangChain.chatModels, import, I don't know, OpenAI, whatever it's called. Okay, so feel like it is familiar because it is. You've already seen it. It's okay. So this is just an example, okay? So we have already seen the OpenAI like usage, right? And that's the package. We used it, we called import OpenAI. We have also seen how we can import something specific from a package, which is from transformers, import pipeline. Pipeline is a big old giant function. And so we see how we can do that specifically. This is what LangChain is looking like. This is a graphical representation. Thank you, Umang, for sending this over. This is a graphical representation. And you can see here that these are some of the modules that we specifically have within LangChain, okay? And we just saw that on the GitHub. And so the thing about APIs that we like is that one, lots of different people make them. And so there's lots that are available to us. We are standing on the shoulders of giants. And so we're not writing our own LangChain, we're using what LangChain has. And when we want to extend it, because it's open source, that is something that we can do, okay? So APIs, a lot of them, very helpful. They do something specific, but what's great about them is they tell you how you need to interact with their framework. So essentially, what classes do you have available to you? And in those classes, how do you need to input the parameters? How do you need to input or set up the attributes? It tells you every single little thing about those things. And that's what the API is. It's a contract between you essentially and the developer that when you pass something in or that it will have this behavior and it will do this particular thing. So it's just a contract about the inputs, the outputs, what's available. So I think we have 4 minutes left. So clearly we're not going to do this breakout room, but I do, okay, let me decide which one might be best. Maybe let's try this OpenAI documentation. Oh, I just opened it 1600. So this is the actual API, right? So not the documentation. This is the actual API reference. Sorry, I just really opened it. Oh no, now I didn't know. Okay, so this is the actual API reference. So the API reference is going to look a little bit, again, you should look at it and think about it as a contract. It will tell you exactly what you can pass in, what methods you can call, what functions you can call, what classes are available, and what they do, those types of things. So when you first start looking at this OpenAI reference in particular, it looks kind of crazy. Wouldn't start here, but start with documentation. But how you use this, when you see this, look for the Python. This is not Python. Look for the Python, number one. And then number two, look in the sidebar and make sure that you have the right thing selected. This is nothing that we would write in Python. We will use this. So make sure you have the Python selected. So again, this is the API, right? It's the contract. It's telling us how we can interact with their platform. And what is it saying? It's saying that for this create completion thing, this is the syntax that you need to be able to call to create something. Completion for the provided prompt and parameters, right? It says you need to pass in model. It's required. Remember how we talked about things that are required, and often the most important thing is first. There it is. It's a string and it is the model that you want. So here we see all the contractual things that you can do. Remember how we talked about default values? Here they go. You can add a suffix, you can add a prompt, you can add a temperature, top P, whatever have you. Remember how we wrote those things in our functions? There they are. You can put them in or not, but the only thing that's required is this. And so now you see the contract. These are things that you can pass in. If you pass in something else, you've broken the contract because it'll have no idea what you're talking about. If you don't pass in something that it requires, such as this model ID or this model string, then it will equally be upset because you have again broken the contract because you haven't done what they needed to have from you to do what they needed to do. Okay, this is where we are. Thank you for sticking in there with me. Sometimes I get really excited about object-oriented programming and you're like, where are we going with this? But this is where we're going, that you have actually created your own sort of mini LangChain package. You can actually take a look within it and see how a package is just set up. But we also saw this in the actual LangChain GitHub. Okay, and so we've actually, this is the source code. So you've looked at source code today, you've looked at an API reference today, and you've also looked at a quick start today. So you are just like really on the roll to be able to start strong with LangChain next week. Of course, we do have a last session of AI assisted programming on Friday. I did assign some homework in this notebook, and so you should take a look at it. I would also encourage you to look anything that wasn't clear today. Do try to use one of your generated AI models, but if you look at the answer and you're just not quite believing it, please feel free to ask any of those questions to us as well. And with that, I will see you on Friday and have a good rest of your day. We'll have office hours for the next hour.
Thanks, Charlie.
No problem. Maybe I didn't include the homework. No problem.
So are we just able to ask you guys questions?
Yes, and if there are a lot of people that have questions, we are happy to separate into breakout rooms so that maybe we can parallelize the questions. But yeah, just ask away.
Okay, so so if I want to create my own information, I don't know if it's called a LangChain. I'm not totally sure how to ask this question, but I want to create my own information of where I want to draw the to train my AI model from. So like, and if it's whether it's in a database or like I don't know how to get it into a model necessarily to say, hey, let me call upon it to use it. Like the source, the actual source information. And I have some specialized source information that has to do with structural engineering is what I do.
So are you talking about specifically training the model or more just directly using the model?
I'm talking more about training the model. Like I want to create my own parameters and my own information that goes into there that I want it to draw off of when I submit new inputs. I want it to keep always using that same information. And as that information gets updated, say it's a 2017 code book, or if it's a 2020 code book, I want it to be able to use information from one code book. And then if I say, okay, fine, I want to use it the same, I want to get the same information out, but I use a different code book, but I need to train it to tell it to say, okay, here's the information for the 2017 code book, and here's the information for the 2020 code book.
That is a great question. So I am not sure that training is actually necessary. I would try a model that that is generically like acceptable. But Miranda, hopefully, if it's okay, she can tell you more about LangChain and document stores and how they can work with a model before you step into the process of training a model if that's not performant.
Yeah,
Okay.
I was going to jump on in here. So what you don't actually need to train the model, which training would involve like, starting the model from scratch where you just have, base, it hasn't learned anything, and then you give it all of the information and it only has what you trained it on, which is what you're saying with the documents. But what we could do is take these large language models that other people have developed that have already trained them on all of the language things that they did. And then we can give them our own personal document store and have them answer questions about that. So that sounds a bit more like what you're wanting. Is that correct?
Yes. So what are you saying? I mean, my books are thousands and thousands of pages long. I mean, there's probably, 10 different, large books of information. So are you saying that I'm putting, or either I am getting that information from another spot and saying, use that information?
No, so you can upload what you have.
Okay.
Right. So I'm assuming it's got to be digital. And then so you can create what we're going to call a vector store, which is going to be like an embedded version of those books. So we'll take the model embeddings, apply them to your books so that they are understandable by the model, kind of just turns them into numbers that the model can interpret. And then you can ask that model questions about the information that you have given it. And so we will be learning how to do that next week in LangChain, but I am happy to discuss it further here.
Okay, thank you. But that is what I
Yeah.
need to start learning about, is more the LangChain.
Mm-hmm.
Right.
Okay. All righty. Thank you.
No,
And
no
I
problem.
could jump in briefly with Janet's question because I know we connected like on the structural engineering side, and yeah, like going from her side thing, like we were both asking the Bing model, I think it was, like questions on this, and it was struggling. And me kind of thinking through it, like I feel like there might also be an issue with the theory, like mathematical theory of these designs. Like if you're going through a whole steel design document, I don't know if the model would fully understand those concepts unless you tried to train it or gave it a ton of information.
So are you?
Go ahead.
Oh, I was just going to say, do you happen to have one of these pages that would represent like what you are talking about? Because I'm thinking about the page of like, so I did my PhD in electrical engineering. I'm thinking about one of my textbooks and then a page that is just like full of derivations. Is that what you're sort of, no? Yes, yes.
Well, both. It would be like, okay, here, for this piece of the puzzle of what I need to solve, here, go to this reference, and it is, a reference, a table that's, 3 pages long. So go to that reference, find the information that I need based off of this parameter. I mean, I can just use an easy example of design pressures for wind for Windows. And I have you know, a 3 foot by 5 foot window. What's the design pressure for it, and that kind of thing. But it needs to not only look up that table, it also has to look up, okay, here's my location. It's based in Florida. You got to do the exposure. We've got, like, there's a bunch of different parameters for that. And I want it to look up all those different tables and all at once, because that's what I do now. So I want it to look up reference all of those different tables from this one document. However, I have it put into a different format so that the computer can figure out what the information is. So.
Yeah,
so
yeah. Okay, so now this is sounding more to me like using agents. Would you agree, Sharo?
Yeah, I was thinking either agents, I mean, I think it is agents, but some sort of iterative like call, because almost, so a piece of it sounds like table question answering. But if there are other pieces in it, then agents, or at least chains, you know.
Yeah, like I could kind of add again, like, for example, like say you're designing that window in like Florida, you would have the Florida building code for that window. You would have the mathematical theory for window design, and then you would have a table of specs of like, these are what you can design with this thickness or dimensions. So like 3 different tables at a minimum, probably.
No, Miranda, I think you nailed it then. I think you nailed it. I think it will be agents.
Yeah, and so that's another wait until next week. We'll be talking about LangChain and agents and all of that. So agents are basically that you can think of them as kind of, you know, autonomous, where you give them a task and then you can give them tools. So you can give them your documents, you can give them an understanding of math. So if we plug in something like Wolfram Alpha for calculations, and then you can give them you know, if there's a tool for searching for the Florida codes, or understanding that it's in Florida, and it will think through the prompt that you give it, and go through the steps to accomplish that task. So it'll say, oh, first I need to look at Florida codes. Here are the Florida codes. Next, I need to look at, you know, the calculations, and here's how I do those calculations. And so, yeah, and I mean, this kind of stuff is changing all the time. So I always say, like, when I give a potential solution, it may change next week. And, you know, they may come out with something that does even better. But I would say LangChain with agents, which we will touch on next week.
Okay, so let me just, if I heard you correctly. So when you're saying, I'm asking it, you're saying I'm going to program in this particular information, like, this is the task I wanted to do. Here are the parameters that I have for this specific project. And then it's going to reiterate through using agents, because the agents are going to connect those questions to each of those iterations. Is that right?
Yeah, so it won't exactly yeah, it will iterate if it doesn't find an answer. Yes, I'm going to say yes to that. Sorry, I just had to think about it.
Okay.
All right. I think also if you do want to, so I think agents is the answer. But if you wanted to begin with something, maybe if you want to start somewhere that isn't, well, I don't know, that API, I don't know, you might be set after next week or the next week. But you could start by just asking like a sequence of questions, or you could just leverage like a chat sort of functionality, unless it needs to go out and get something, and that's where the agent comes in. But I mean, maybe the chat to some extent would do it. So you would first ask for, I don't know, the Florida blah 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 code, and then you would, after it returned that, then ask it for blah 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 blah, and then ask it after that for blah 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 blah. And then since all of that is in the chat history, then it would be knowledgeful of these things.
Well, let me ask you this. What about if I'm trying to, here's my task of what I want to do. Will the AI tell me, like, hey, I can't do this because you haven't given me the exposure. Please, input the exposure, or will it not prompt me to say, hey, I don't have enough information. If you give me, and here's the information I need, will it do that?
If you prompt it correctly. So it's kind of one of those things where it is trying to come up with, the most likely thing to say. And so sometimes it's just not right and it doesn't know, so it just makes something up. But in your prompt engineering, you can say, if you don't know the answer, use only this document for your answer. And if you can't find the answer, then tell me what information you need or something like that. And that's something that you kind of have to hone in on yourself, because I don't want to say this exact phrase and then it will be right, because you still want to check it and then change your prompt accordingly.
Right.
Yeah, I think that, as Jesse would say, a lot of it is empirical. I will say the other day, so there is something called an inversion prompt where you can say, like, keep asking me questions until you have enough information to actually answer the question that I'm looking for or generate what I'm looking for. But also the other day, I just happened to ask it to explain some code and pass in any code and was like, hey, I can't explain anything to you until you give me the code. So in some sense, like, it definitely does see things that are missing, but for the kind of technical word that you're looking for, maybe it might fall a little short.
Okay.
Maybe you could provide it, maybe you can like chain of thought it a little bit. So maybe you provide it like the information about how the problem is solved, then maybe solve a problem with it and then ask it to solve the problem that you're actually after.
Okay. I will try that. All right. Well, thank you.
No problem. Let us know if you have further questions. It sounds really interesting.
Thanks.
Can I ask a question? It's sort of piggybacking on Janet's question, although not exactly, but it's similar. Let's say you have a book that you've written that's not in the public yet, or you have part of a book that's, let's say, a few hundred pages, so too big to put in a prompt, and you want to ask your model generate the beginning of the next paragraph. How do you get that in the model, because it's too big to put in the prompt and it's not yet in public domain?
Yeah, that is tricky, because whatever you send to OpenAI, it's kind of theirs now, right? So they're going to use it. So I wouldn't send any original writing. This is just me. I wouldn't send any original writing. You can, maybe run a local model like Llama or Alpaca that is smaller on your own machine. But as to your question, in generating the next, paragraph, it doesn't need, it does in a way need the context of the entire book, but to generate a specific paragraph, I don't think it would need like the whole book before, right? Especially if you're just working on a chapter by chapter basis. I haven't done much of generating. Well, I don't know, Sharo, do you have ideas about this?
Oh,
like, I think you could say generate something in the style of this document. I don't know if it would pick up on where it goes in the end.
I have a really super weird suggestion, which is something that I saw. So anyways, so essentially what someone did is they asked like ChatGPT to condense this information in the smallest size possible that it could still understand. And so what it did is it essentially just boiled everything down to like something that is dramatically shorter that still seems to have all the information. And the person took that and they put it into a different instance of ChatGPT, and then they asked the question about it. And so that, like, it kind of shortened the context. So you're able to add more information with less context taken up. And so that could be a way. Also, they're able to sort of re-represent data with different, the best way I know how to explain it is that I like to, okay, have you ever heard of wingdings? Do you remember wingdings? No? Oh. So basically you can choose to represent things with symbols that makes whatever your input is much shorter. So now
Okay.
you put those things and you can put it into, you have less context that's taken up by the same amount of information. There was something else that I wanted to say about that as well. Yes, and also Llama. So if you don't want to use like OpenAI, like Llama, I think 7B can run on a computer. And then there's like an alpaca training methodology that apparently, I mean, it takes like $600 apparently to train this model on Google Lab. But $600 is like, apparently they didn't try very hard to reach 600. So there might be better mechanism to do it. And that trains it with the reinforcement learning from human feedback. And so maybe if you need to have like your own model, that is something that can kind of meet that need if you don't want to use something like OpenAI.
Okay, great. Yeah, I'm not so concerned about the privacy as much as I just don't know how to get such a big prompt in. I can't put the entire content in the prompt.
And then,
which sounds like it's similar to Jen's issue where she couldn't put her entire code book into the prompt even if she wanted.
I mean, I think with yours, it's interesting because it seems like your goal is to use the entire text.
Yeah. I mean, I almost wanted as if that content was in the open domain and it was built into the actual model. That makes sense. Yeah.
So what I will say is with hers, it is a little bit different because she only needs like pieces of any individual book, right? So if you want the whole book, actually, when I think about it, maybe what you could do is just train a smaller model. You could fine tune a smaller model. So use something, so you could use GPT-2 or one of the Hugging Face models or something, which is like smaller, or any of the other models that do like causal language modeling. And then you could train it. Yeah, you could train it something smaller. So something that you can run on Colab for free. And it's just fine tuning. So the model weights are mostly there. What you're trying to do is just like edge in this little extra information about this particular book. That could be an approach, but you can also, I think that we also heard from Jesse maybe yesterday that there is some language model out there that has like 100,000 token context or something. And so that might do it.
Okay, thanks for those suggestions.
No problem.
So I want to follow on to that. How would we do that? Like, is there information out there about how to take one of these smaller models to kind of fine tune it? Because I think a lot of faculty are going to have the same question, right? Like I have a significant amount of content, and my kind of like a book or a textbook, which is a lot of information. And what I'd like to be able to do is set it up for students to do like question answering on. But I want them to kind of only be looking at this content, right? Like I want them to get it from this textbook, not just from the web, right?
Right. So for that, you wouldn't need like a self-trained model. Like when you want the model on your local machine is when you don't want to send your prompt to like OpenAI or something. But for what you're saying is not too hard to set up with LangChain, where you can put the whole book in a document store or vector store, and then use some of the chains in LangChains are question answering with sources, conversational retriever chain, and you can set those parameters on that to be only get information from this text, put your source in your answer, show me where you got the answer, stuff like that.
Okay, and that's what we're going to be doing next week, right?
Yeah.
Okay, great.
Then I just had one question like related to, since we're talking about tokens, like I know going through today, it was talking a lot about like padding left for the input and padding right, if I'm understanding, or output, if I'm understanding correctly. Like, can someone just explain like that at a higher level idea, I guess, or understanding?
So it was asking, where did this occur with the padding left and right?
Yeah, well, I was working with GPT-4 and I was having some issues when I was coding some of the stuff. It was like, yeah, you can try like padding left for more input tokens. So
So basically what I think it may be trying to say is that, I don't know why it was, I don't know what it's trying to get at, but I think what it may be trying to say is that, so with the code that you were using, was it that like auto model for like causal something, or auto model BERT something? Did it have like
just the
encode, decode?
GPT to like just basic.
Did you use it with the pipeline, or did you have like other code that's like encode, decode, generate?
It was very basic. Like I'm with Python, at least I'm very basic code. So it wasn't like super anything advanced at the time.
Okay, I'm just trying to think about why it might have said that to you. I think so. So we went over, like someone proposed an example today in class where they used like auto model for causal language modeling. And they use like auto model for, I don't remember what it was called. But when you use that methodology, it can make it it makes it so that your like the way that you interact with the API for transformers is a little bit difficult. And so that means that you on your own have to prepare the inputs to go into the model. And so if you pass in like some inputs, what it will want to do is make sure that those inputs are all the same length, because that's what makes it easiest to go into the transformer model. And essentially that's the only way you can sort of like represent this data that's over here or there. So because it wants them all to be the same length, if you have examples that are differing lengths, that means it has to pad it to some length, right? So it's padding. So maybe you have some text that I am a dog. That's your first example. Your second one is I am a dog that runs really far. It's super cute. And so it's super long. If you want to run those two examples together, you have to pad the first one all the way up to the size of the second one. And then that is what you put into the model. And it matters whether you pad on the left or the right, but that has to do with the kind of model that you're using.
Okay.
And
Yeah,
to be clear, like that's not something that you should need to be doing for the purposes of this.
Yes, that is like something that's pretty like in depth.
And I wasn't trying to understand the programming. I just want to understand like the mentality of it. And that's what you were speaking to, like what it actually did.
Yeah, it makes it so the model can digest it, especially in a batch.
But no, thank you. That was my main thing. So I appreciate it.
No problem. Thank you.
Just wanted to say thank you, dropping off.
Sounds good. I sent you a message in the chat about Transformers agents. So it's
Okay.
not LangChain, but it has a Colab notebook at the very beginning of it where you can kind of see what we're talking about with that, you know, logical sort of reasoning.
Excellent. Thank you.
No problem. See you. Thank you for coming.
Thanks.
I had a quick question. So where's the homework? I couldn't find it on the API collab notebook.
I truly thought I had put it in there, but maybe it's only in the solutions.
Also in the solution, I can't find it. Both in like the congratulations part. Like in the solutions.
I bet I deleted it.
Okay. So
That's really upsetting.
sorry about that.
No, thank you for
Thank you.
letting me know. I'm trying to think
Yeah.
about what I even wrote there. Sometimes I write things down. I'm like, this is a great thing to do. And then I just immediately forget. Oh my gosh. Okay, I will try to come up with some homework, but it may be that it's not, maybe I'll try to update these, but it may not get updated.
Sounds good. Thank you.
No problem. Miranda, are you set for the rest of these office hours? I mean, I kind of think that we can just sort of, seems like there are no more questions, but I do want to attend that talk on like chat or generative AI in the classroom. You okay?
Yeah.
Okay. All right. Sounds
Yeah,
good.
you want me to just like hang out?
Yeah, let me know if you need something.
Okay.
If and just I'll be on the Slack.
Okay.
Now,
Yeah, I'll be here.
are you the host? Okay, I'm gonna make
I think I'm a co-host, but make sure.
because I was about to click the button and then it would have been game over. Let me see. Make, there we go. There you go. I think you're now.
All right, I am the host now.
All right. Thanks, Miranda. I'll see you and let me know if you need anything on Slack.
All right. So Abby, my Zoom sometimes just takes specifically Jesse Bloker's profile picture and puts it on a random person. And right now it has put it on you. I just thought you should know. Oh, you're muted if you're
Oh.
talking.
I said that's so funny, and he's not even in here anymore, so that's super weird.
No, like I don't know. It's done that. This is like not the first time it's done it either. It just picks someone and then they get Jesse's face. Okay, I think we have like 5 minutes left, but if there's no questions, we could probably just shut this down.
I agree.
All right. If there's no questions, I'll go ahead and end it. Bye.
Yeah.